Hey guys, welcome back to day 16 of SAT ACT Math. Today and tomorrow we'll just be going over some basic formulas here before we move into the grammar section we'll do next. But I just want to do these because you may know how to do all the problems, but knowing if you have strong basics, you'll be able to attack any kind of problem. So we'll go over the SAT formula sheet that you do get. Yes, you get it, but you should know how to do these and you need to know how to apply them. And then we're gonna do some exponent stuff. You guys can so just because there are some harder problems that do deal with these. So if you know how to do that, it makes life easy. Okay, let's start with the circle. Okay, so area equals pi r squared and circumference equals 2 pi r. What they may ask is they might ask for arc length, which is s equals r theta, I think. R equals r theta, just a radius, right? S equals r theta, that's your arc length. But you need to make sure this is in radians if you're doing that. To convert from radians to degrees, you do so you have degrees, so you have to go radians over degrees to cancel them out like that. And then to do that, you go pi over 180 to cancel it out. Okay. And then there's also arc sector formula. How I like to think about these is so I like to think of it in terms of proportions. You have an area, and they want 30 degrees. So 30 degrees is it's it's 30 over 360 times the area if it's asking for 30 degrees, right? Times the total area, so pi r squared. For sector, similar thing, except instead of pi r squared, it's 2 pi r, right? Okay. That's how I try to think of it logically. You should know this. Area of a rectangle is length times width. This is not a trapezoid. A trapezoid's length is different. If you're not sure what a trapezoid is, here, one second. Let me draw one for you. Here. You should know your shapes. And I know you learn them early on, but you forget them. So a trapezoid is like this. So that you want to do. So if this length is constant, you want to add these two lengths, find the average of these two lengths. So this is 10, this is 8. You do 18 divided by 2 to find the average is 9. And then you multiply by whatever this value is. If it's 5, you do 9 times 5, like that. Okay. For a parallelogram, you can still, you can still do like that. So if you know it's like that, you can kind of just use common sense to. I would really suggest use having strong basics and know how to do these. You can go like that. Then basically what you can do is you can kind of just fold this over like that, and you'll get the full thing. Or sorry, no, not like that. If you multiply this entire side by this height or the height, you should get the right answer because this will basically fold over like that, and then you'll get a rectangle like that. Okay. Now let's move into the triangle stuff. So this formula of a triangle works all the time. No, and I don't think there's anything special we need to go over there. But Pythagorean theorem is this. If you're doing ACT, you should know law of sines and law of cosines. Let's go over law of sines first. Okay, here's the formula. So it's sine A over A equals sine B over B equals sine C over C. Basically, it's like this. That's C. It's A. It's B. Sine of A over A equals sine of B over B here. We can, if you guys need more help with that, you guys can request a video there. Basically, for law of sines and law of cosines, you want to keep track of what you have. Law of cosines. And oftentimes in the ACTs, there's not a formula sheet like that, but it might be given in the problem. I think it's this. I will double check after. I think it's B equals the square root or here's what it actually is: b squared equals a squared plus c squared plus, I think it's 2. Um, Here's the more general formula. So it should be c squared equals a squared plus b squared, and then it should be times 2a plus 2ab, but I will double check. Law of cosines is, yeah, oh, sorry, I was close. It's a squared plus b squared minus 2ab cosine of c. Just, okay, so here's how I remember it. So everything else but this is, you know that this is only appears once in its cosine form here. Okay? And then a squared and b squared, other two that are left. And then minus 2, and then whatever 2 are here. So a and b, like that. It's a little harder, and if you guys need more help with like more specifics, let me know and we can go over that. Law of cosines is technically, this is a subset because basically your sine of c is sine of 90 is 1, so that just kind of cancels out in a way. Now we'll just do some special triangle stuff. Okay, it says right here, this format, it's good, right? But here's how I like to remember it. It's similar, but 30, 60, 90 triangle. So 30, it's 1. And because it's the lowest degree, it should have the lowest value. 60 here, root 3. And because it's the second biggest one, it'll have the second biggest value. And then 90 opens up to 2. Because it's the biggest, it should have the biggest value. And this is also a right triangle, so if you forget one, if you remember 2 of them, you can find the other one out. And then this one's a little bit. This one is sometimes a little bit tricky to use, but this is the 45, 45, 90 triangle. You just know that like that. So 45 opens up to 1, 45 opens up to 1, 90 opens up to root 2. If you think about it, it's 1 squared plus 1 squared is 1, and then take the square root of that is root 2. Okay. Okay, area of a cube or area of a rectangular prism is length times width times height. And for a cube, it's s cubed, or length cubed, if you want to call this s, or if you want to call it l cubed. That both of those work. Okay. Area of these two, area of a cone and area of a cylinder, they're the same except a cone is 1/3 as much. Okay, so think about it. If you have a circle, you're just multiplying by this height here. Here, if you think about it, it's a it's a cylinder, but it's 1/3 because you see this entire thing is gone. It's just 1/3 of that. The area of a circle is just something you're gonna have to remember. It's a little bit I don't know how it's derived, but it's given to you. So worst case, yeah, that one. And then this one is also a little bit tricky. I would probably refer to if you're getting I think it's called a square pyramid. If you're given it, I would just use the formula, honestly. I haven't seen it as much on any of the tests recently, so I don't know if it's too big of a deal. So anything to the power of 0, 1. Okay, and if you have, as long as they're the same bases, 2 to the 2 times 2 to the 5th, you can just add them. Just go 2 plus 5, so 2 to the 7th. You got to make sure they're the same bases, so the 2 and the 2. 2 to the 2 to the 6 times 4 to the 6 is not the same, but you could actually, we'll come back to this, but I'll show you what there's always like an SAT problem like this. I'll show you what it is. That's the product rule. The quotient rule, similar, but not the same. If you have here, I haven't seen this much either, but it is there. If you have the same bases like this, you can subtract them like this, as you can see. Whoops. Like that. Power of product. This is basically, I kind of like to think of it as like kind of distributing it out like that, and then you're left with that. Okay, so if you're given 6 over 4 to the power of 4, you kind of distribute it out like this. And then anything, so if you have a to the power of 6 to the power of 4, you can just multiply these two and you get a to the power of 24. We'll come back to this rule with this problem I came up with up there. I'll show you how to solve that one. Yeah, if it's a to the power of negative anything, it's you can just turn it into 1 over a to the power of m. Might make it a little bit easier if you have to simplify, and sometimes they might ask you like, oh, a to the negative m, a to the negative 2 times b to the negative 3 times c to the negative 4, and then ask you, or positive 4, I'll say, and then they ask you to make it simplified. Then you have to bring these two down like that into the denominator and do it like that. They might ask you that. And then the fractional exponent, so if you're given a to the power of 2/3, technically it's actually, here's how I like to think about it. It's technically a to the power of 1/3 times 2, right? So you can do the 1/3 and then times 2. You can do them both separately. So the 1/3 comes here, so you're given 3a. Don't forget about the 2. So it's squared. Like that. Outside the parentheses, sorry. Outside the parentheses like that. Okay? Sounds good. Now here's the problem I was talking about. So if you have 2 to the power of 6 times 4 to the power of 5, can you just add these up like that? No, you can't. What you have to end up doing is you end up turning this into 2 to the 6th times 2 to the 2 to the 5. Okay, you can split 4 into 2 squared, and you can still need the 5. So then what you end up with is 2 to the 6th times 2 to the 10th, and then you can add these, so you get 2 to the 16th. That's your final answer there. Okay, we'll go over these rules today, and then that'll be it for today. For growth and decay problems, I would remember these, but if there's growth, you add the rate here. So if there's 6% growth, 1 plus 0.06. Make sure if it's 6%, you don't just add on 6, because that's technically 60%, not 6. Okay, so if it's 60%, you don't add on 1 plus 60. You need to do 0.06. Same thing here, and then this is the amount for the amount of time, and this is the principle. I like to call it. I like to do PIRT. So, oh no, sorry, I equals PRT. So I equals PRT like that. And then it might say increase by a factor of 2 every 5 years. So you could go like P2 and then T over 5, right? Like that. Okay, I think that's it for today. Did a good amount of stuff. I have an entire sheet with everything I used to get my to get a high score. I'll go over the rest of that with you guys tomorrow, and I think we should be able to get it all done tomorrow. If not, we'll do another day. But this is day 16 out. Thank you guys for joining me. If you guys want any more content like this, please let me know. We'll probably end up doing another day of this and then going to SAT writing. Please subscribe and please like this video. Thanks.